What is up, my people? IQ Kid here to talk about the product rule. So the product rule helps us when we're trying to take the derivative, but otherwise we couldn't because the two functions are being multiplied. So the product rule lets us know that taking the derivative of this two functions being multiplied gives us the derivative of the first times the second plus the derivative of the second times the first. So I like to think of it as first d second plus second d first. It's just kind of catchy and easy to remember. Alright, so let's go ahead and look at a few examples. So in the first example, let's take the derivative of the function f of x equals 3x squared cosine of x. So to start, step 1, let's write the formula. So h of x is equal to f of x times g of x. So h prime of x is equal to f prime of x times g of x plus g prime of x times f of x. Alright, so now let's take the derivative of each component function. So each of those are the two different component functions. So d over dx, that means the derivative of 3x squared is 6x, and d over dx of the cosine of x is negative sine of x. Alright, so step 3 is to plug and chug. So let's go ahead and do f prime of x, since the function is f prime of x equals first d second, so 6x cosine of x plus second do first, so minus, since it's a negative, 6x sine of x. So this is your final answer. Okay, let's look at another example. In this case, we're going to look at taking the derivative of the function f of x is equal to 2/3 x cubed times e to the x. So e to the x, when you take the derivative of that, it's actually e to the x. That's the derivative of e to the x. It's kind of confusing, but if it were, say, e to the x squared, so like if it were e to the x squared like that, then the derivative would be 2x e to the x. And so just so y'all know, okay, that's a side note about e to the x. Alright, so step 1 is to write the formula. So let's see here, h of x is equal to f of x times g of x. So h prime of x is equal to f prime of x g of x plus g prime of x f of x. Alright, so let's take the derivative of each component function. So that's component, that's component. Alright, so d over dx, take the derivative of 2/3 x cubed, and you get, so 3's cancel, so that's what, 2x squared. Okay, and then the derivative of e to the x, as I just mentioned, is e to the x. Okay, so now let's plug and chug. So f prime of x is equal to, first derivative of the first is 2x squared times the second, e to the x, plus the second derivative of the second times the first. So that would be e to the x times 2/3 x cubed. So let's go ahead and rewrite that as f prime of x is equal to 2x squared e to the x plus 2/3 x cubed e to the x. That's your final answer. Alright, let's look at one last example. This example is going to be a little bit more difficult because it has two parts. Alright, so yeah, this one has that component and that component, and then that component and that component. So let's call this set 1 and then that set 2. Alright, so step 1 is to write the formula. So h of x equals f of x g of x, and then h prime of x equals first d second plus second d first. Okay, so step 2 is to take the derivative of each component function. So the derivative of x squared is 2x. The derivative of sine of x is the cosine of x. The derivative of 2x cubed is 6x squared, and then the derivative of the cosine of x is the negative sine of x. So step 3 is to plug it in and then simplify. So plug and chug. So f prime of x is equal to first d second, so the derivative of the first is 2x, and then times the second is sine of x, 2x sine x, plus second d first, so x squared cosine of x, so that right there is 1, and then plus 6x squared cosine of x, and then minus, since it's minus sign, 2x cubed sine of x. So that right there is part 2. So part 1, part 2. Alright, so yeah, that's your final answer. And yeah. So I hope this helped. Thanks for watching. If you have a question or would like to make a suggestion for my next video, you can contact me through the email in the description. And yeah, so have a wonderful day, and always make today better than yesterday. Like, comment, subscribe. Until next time, IQ Kid signing off.